We are 4.3, continued. Yes?
We always learn the hard stuff first.
Okay, let's go back. What do you mean the hard stuff first?
The more complicated, longer way.
Like, are you referring to this right here, a problem of the day?
Yeah, like, and then the easier stuff.
Well, sometimes we have to get the foundation of this is how it works to appreciate how to do the things that feel kind of like shortcuts. Do you see what I mean?
Yeah.
Okay. So yes, I get that Riemann sums may be like the bottom of your list on things you like about calculus class. Okay? But it's the foundation for us to set up how do we really find the area under the curve. Okay? All right, so some areas that we see can be found using basic geometry. Okay? If you have a line, could you make a triangle between the line and the x-axis? Okay? And instead of doing a Riemann sum, like we did in our warm-up, okay, we could find the area of a triangle, or two, depending. Okay? Sometimes we may have a semicircle. Okay? Well, we know how to find the area of a semicircle. We don't need calculus for that. Okay? So if your curve represents a shape that we can find its exact area without calculus, let's do it. All right? That's essentially what we're going to be doing today. All right? For example, okay? The integral from 1 to 4 of 2 dx. Write it down. I agree. A Riemann sum is a lot of work. Okay? But we know 2 is the function that's a horizontal line. Yeah. So from 1 to 4, we have a rectangle, right? Here is the line y equals 2. And if we only want it from 1 to 4, we're talking about this area right here. So 4 times 2, is that what it is? Really?
Oh, wait, no. 3.
3 times
3 times 2.
So the area under the curve, y equals 2, from 1 to 4, is 6. Done. Right?
Seems too easy.
Too easy?
Oh, you turn it into a triangle.
Yeah, or trapezoid, either way. Okay.
Oh, yeah.
But you know what? That's the beauty of math sometimes, right, Trevor? Some of us see a trapezoid, some of us see a rectangle and a triangle. Do we get the same area? We sure do. Okay? So any linear equation, we're going to be able to use geometry to get the area under the curve. Because either we're going to get a rectangle, a triangle, or a trapezoid. Okay? Or a rectangle. Right? All right. So if we want to find this area, you see that I have graphed the line. And then from -1 to 2, blocks that off. All right, so how many of you vote we use a trapezoid? It looks like a majority. Okay, so our trapezoid, 1/2. What's the height of our trapezoid?
3.
What's one base?
No.
Plus, what's the second base?
Quattro.
Okay, so the height of our trapezoid was 3, base of 1, base of 4, we have an area of 15 halves. Or 7.5, I don't care. Either one. But that is the exact area. All right. I really need you to get used to seeing this equation right here, or something like it. The square root of 1 minus x squared. What is it?
No.
It is irrational, but what is it? Okay. The square root of 1 minus x squared is a semicircle with radius 1. Since we're going from 0 to 1, we only care about the quarter circle, 0 to 1. Okay? But you might need to make a note to yourself that if you see the square root of r squared minus x squared, it is a semicircle with radius r. You're going to see a lot of that, especially in this section, since we're talking about geometric area. Okay, so since it's 1 minus x squared under the radical, we have a semicircle, it would technically be all the way to here, right, of radius 1. But since our integral is only from 0 to 1, then we only care about the portion in quadrant 1. How do we find the area of a circle? Pi r squared, since we have how much of it? A fourth? 1/4 pi r squared. The exact area is pi over 4. Okay? Which is actually good because we don't have a way right now in this class of taking that antiderivative. Okay? So geometry is the only way we're going to be able to do it. Okay? I need you to be able to recognize a semicircle. I really do. It's going to help you a lot. Obviously in this section, on the quiz, on the test, but here on out, I need you to be able to recognize a semicircle. Someone's phone is on mud. I can hear it beeping. All right. Jackson pointed this out in the problem of the day. Why was our problem of the day negative? Jackson said, well, because we have area under the curve, or under the x-axis. Okay? Let's talk about that. 2x is this line right here, and I had you find the area from -2 to 1. So notice how some of the area is underneath and some of it is above. Okay? What's happening? Any of the area that is underneath the curve is negative area. And any area of, I'm saying this wrong, any area beneath the x-axis is negative area. Any area above the x-axis is positive area. Okay? Yes, I get that we don't have negative heights for things, but when we talk about the x-axis, we kind of envision negative rectangle heights when we're below. Okay, because we're going in the negative direction. Okay, we take that pretty literal. Even though rectangles can't have negative heights, they can have negative orientation, if you will, when we're underneath the x-axis. Okay. So on the next slide, there's going to be a picture with some numbers about the area. I'd like you to draw the picture so that when we talk about different things about the picture, you can have that to reference in your notes. So please draw this picture, labeling A, B, C, D, and the area for each region. Okay, so let's talk about what we can do with this. Okay. If I ask for the integral from a to b of, so I'll name this f of x dx, what would we say? We would say 5. The area from a to b is 5. That's what it's asking for. However, if I ask for the integral from b to c of f of x dx, what would you tell me? Negative 4. The area from b to c is 4, but it's under the x-axis, so we have to say negative 4. All right. Oh, sorry, people. That's what I wanted. Okay. The integral from c to d of f of x dx would be 3. All right. Boring, Mrs. Holman. All right. The integral from a to d of f of x dx. What would we have to do? We would have to add them together. So we take the area from a to b, add it to the area from b to c, add it to the area from c to d. So the total area underneath this f of x curve from a to d would be 4. Okay. All right, same thing. I'm going to give you some time to draw a picture. Because without the picture, the example in your notes will mean nothing. Okay, so what I am going to ask us to calculate is the integral from -7 to 5 of this function. Okay, so I'm asking for the area underneath the curve from -7 to 5. Now, this is a very chunky graph, right? It is not differentiable everywhere, so we're going to have to break it up into pieces. Right? So, first piece I see from -7 until where? Okay, so from -7 until -2, it looks like we have a triangle, right? A triangle, 1/2, the base would be 5 in length. The height would be 1, but since it's underneath the x-axis, it has to be negative area. All right, negative 1/2 5 times 1. Plus, the next chunk we see looks like a semicircle. Okay, so we're going to calculate this area. Semicircle, 1/2 pi r squared. And what's our radius? Okay. All right. Next, we have a triangle. Okay. The next section of our graph has to kind of be split into two separate triangles. Do you agree? All right. We have this positive triangle up here. And then we still have like this little piece down here. So let's talk about this green triangle. Triangle, 1/2 base times height. What's the base? 2.5. And what's the height? 3. Okay. And then we have this triangle down here. All right. 1/2. Base is 1/2. Height is 1, but since it's under the x-axis, it needs to be negative area. Okay, so help me out. What do you do when you add all the non-pi numbers together? Okay. So 1 plus 2 pi. Okay. More than likely, that's how you'll see it. Now, if this is a quiz or test that you have your calculator and you give me 7 point whatever it is, that would be fine. All right. But if this were like a multiple choice type of question, more than likely they're going to leave it as 1 plus 2 pi. I don't care either way. Okay. All right. Very quickly, let me refresh your memory. You have written these down. No need to write them down again. But let's recall. The integral from a to a is going to be 0 because I'm basically asking you for nothing. A to a, there's nothing there. All right. The integral from b to a is opposite the integral from a to b. Okay. I want you to think of it as like you're going backwards, right? If we're over here, the integral from a to b was 5, but the integral from b to a is -5 because we're going backwards. Okay. And then the other three we've kind of talked about, but I'll reiterate this third one. The integral from a to c plus the integral from c to b is the integral from a to b. We used that right here to get the total area. Okay. So what I want you to write down in your notes, this is the last example, is this right here. The integral from 0 to 5 of f of x dx is 10, and the integral from 5 to 7 of f of x dx is 3. Without this, your notes will mean nothing as far as going back and looking at this example. Okay. Given those two pieces of information, the integral from 0 to 7, what do we have to do? We have to add them together. This equals the integral from 0 to 5 plus the integral from 5 to 7, which would be 13. How about this? The integral from 5 to 0. Okay, we have to take the opposite of the integral from 0 to 5. We're going backwards. The integral from 5 to 5 of f of x. 0. If our limits of integration are the same, we get 0. And then the last one here, the integral from 0 to 5 of 3 f of x dx. First of all, what are your thoughts? Your thoughts are 30. Okay? Remember, a constant multiplied can be taken out. And we know that the integral from 0 to 5 is 10. So yes, 30 is correct. All right, challenge. I have a multiple choice question that you need to figure out with your pod in the next minute. Okay, let's vote. A, B, C, D, E. 4 minus the absolute value of x. Looks like this. What is that?
Triangle.
A triangle. Base of 8, height of 4. Anytime you see an absolute value, you can graph it and use triangles to figure out your area. All right, your homework assignment is the 4.3 continued, wherever that is on your gold sheet. It is a book assignment. Okay, I won't see you tomorrow. Just block scheduling. I will see you at 8:20 on Wednesday, and we have to get through 2 lessons on Wednesday. That means 2 homework assignments Wednesday. Those are.
No shit.